Hello everyone, very good day. Today we are going to discuss on sequencer, important system design component. Sequencer can be used to uniquely create IDs for every event. Consider a distributed system where we have so many events flowing in through user requests or user actions, and it happens throughout the geographical locations. So sequencer plays a role in providing a unique ID to those events or user actions. Let us move on. So there are millions of events happening per second in a large distributed system which spans across all geographical locations. Example, we take it Facebook, Twitter, or Google. So commenting on any social media or posting a picture on Instagram or few such examples of such events. So we need a way to distinguish these events. One such mechanism is providing a unique ID to each event. So on to the further slides, we will look into what are all the possible approaches, solutions we have in providing a unique IDs to those events. So how do we design a sequencer? In general, this is the requirement or functional requirement. Design a unique ID generator. So we should have a web server that should provide us a unique ID. It could be UUID or a database or a range handler. We will see what is UUID, database and a range handler in the upcoming slides. The second one is unique IDs with causality. So we incorporate additional factors of time such as generation of IDs or relation between these two events. So while generating a unique ID, not generally give a plain and simple unique ID, but also consider the factors of timestamp, vector clocks, or Google's TrueTime API. So add those factors so that we will not run into issues even if the server goes down, comes back in a distributed system. So the requirements of a unique identifiers are uniqueness. Of course, for any unique ID generator, whatever the different events happen, even though it happens at the same second or a nanosecond, and also it could be different events but happen at the same timestamp, or there are two or three events which are related one after other. So we need to maintain the uniqueness, scalability. So the ID generation should give a unique ID to billions in a day. So availability, it should available for even nanoseconds. 64-bit numeric. We restrict the length to 64-bit because it will be available for upcoming future as well. So considering the future incoming request or events, having a 64-bit unique ID generator is a efficient one. So let us calculate how the 2 power 64 or a 64-bit unique ID generations can generate. So estimated number per day could be a billion, consider. So it will be 10 power 9, but we have, so the number of events per day on the number of events per year is 365 billion. So having a 64-bit 2 power 64 will satisfy this requirements. So the first solution, UUID. What is UUID? UUID is universally unique IDs. So this is a Starman solution. So we will start from here and see how we can improve our solution. So this is a 128-bit unique ID generator, and this is how it looks like. So it gives us 10 to the power 38, and so it provides each request a unique ID, and it is independent of the service, and it is scalable. So this is a basic unique ID generator which gives us UUID. Client requests through load balancer, and load balancer distributes this load to the different web servers, and each web service is responsible to generate an UUID, and and the loads distribute. So each, even though it reaches any of the servers, it will generate a unique UUID. So what are all the cons for this approach? As it is a 128-bit primary keys, so indexing a primary key or we are referring a primary key might slow us down in the long run. So this is one of the cons we could think of. And the second solution is plain and simple, using a database. So many of us would have heard this solution. So let us discuss on this. This is just a auto increment feature in a database. Consider a central database providing a current ID and then increments its value for the next ID, and it goes on. So this is how the unique ID generator database looks like. So if you go by a database, there is a central database. How much ever servers there it is there, they will request, and database will incrementally provide the unique ID. In general, it increments from the start value by 1. So what are the cons? So even though this method seems scalable and easy to implement, so the difficulty is it to serve the multiple data centers. And what if a server goes down and the server is re-added again, where the counter is maintained? So let us take an example. Suppose we have 3 servers, and server A generates unique IDs 147, and server B generates 258, and server C generates 369. And what if server B goes down? So and A could generate the any of the IDs which B should generate, right? It will generate 2 or 8. That could be an issue. So these are all the cons of having a increment feature in the database. Third solution is a range handler. So to overcome the previous 2 problems, so we can go for a range server. So we have multiple ranges for billions. So consider 1 to a million, and million to a second million, and so on. So there should be a central microservice which should be handling these ranges. So having these ranges and providing these ranges to the server will help us avoid the problems. Again, this is a high-level diagrammatic representation of a range handler. Client sends a request to the load balancer. Load balancer reaches to the application servers. Then the application servers reaches to the microservice for range handler, and then the microservice takes care of reaching out to the servers and handling the ranges between the servers and returning us the unique ID using ranges. Pros are the systems are scalable, available, of course, and there will be no duplicates. Moreover, we can maintain many ranges. Cons could be what if the server goes down, we lose a particular range. We can, so that are one of the cons we could think of. So improvements. So improvements for efficiency. So this is what we discussed earlier in the slides. So these are all the methods what we saw. First one is UUID. Second one is increment using database. And third one is range handlers. We talked about casualty. So if we have considered in an Instagram, so user A posts a message and user B replies to that particular message, and user C replies to the message which user B posted. So there is a casualty. So there is a relation between these three. So whatever method we choose, upon generating the user ID, we should add these casualties, or we can add after generating a user ID, we can add a timestamp. We cannot generally provide a timestamp alone because timestamp looks easy and simple. What if on a same nanosecond 2 or 3 events comes in at 3 different logical locations? That could be an issue. So these casualties should be combined with the methods what we saw earlier. So this will provide an efficient system which will provide a unique ID. So we should consider the casualty with any of the previous discussed methods. We will have an efficient sequencer algorithm or a system. So vector clock is one such. So vector clock in general, it will have a matrix kind of values for each nodes, and it will increment the request. So in order to provide a unique ID, Google's TrueTime API is a open source distributed class across geological locations. We can get a true time at any locations. So we should combine these two, for example, which I have mentioned here, combine with any of the above mentioned methodologies to provide a unique ID generator. Thank you all once again for watching this video, and also for your patience and spending a time to view our channel. Please do follow our channel for more such videos. Thank you all once again, and have a very good day.